As we know that light is also a form of energy like other forms of energy, for example heat, sound, etc. The problem of its measurement has assumed a lot of importance in the recent times as it is connected with the proper illumination of houses, streets, factories, etc. Can you distinguish which of them is glowing brighter? That is, a bulb of 100 watt or a candle? Certainly, 100 watt bulb is glowing brighter. Now tell me, which candle is glowing brighter? It is not easy to compare their brightness. For this, we require certain standards and special techniques developed under the science called visual photometry. Photometry is a branch of physics which deals with the measurement of light or with the comparison of relative brightness of the two surfaces or of illuminated surface, and the instruments for these purposes are called photometers. Can you tell me what visual photometry is? Yes, the measurement of luminous radiation based on its effect on the visual receptors is known as visual photometry. Let me introduce some definitions regarding photometry. Let us first look at luminous flux. In photometry, luminous flux is the measure of the perceived power of light. Luminous flux of a source is defined as the amount of visible light energy emitted per second by the source. It is measured in lumen. For a given light source, luminous flux is constant and it depends upon the luminous intensity. The SI unit of luminous flux is the lumen. In short, it is written as Lm. Let me define what lumen is. One lumen is defined as the luminous flux of light produced by a light source that emits one candela of luminous intensity over a solid angle of 1 steradian. In other systems of units, luminous flux may have units of power, that is erg per second. People are acquainted with ordinary angles. The concept of solid angle and the term steradian is a bit mysterious if not perplexing. We know what a 90-degree angle looks like, and even if a 90-degree is called pi by 2 radians, we are not troubled. With solid angles, it is a different matter. The problem lies in the fact that an ordinary angle can be conceived of without reference to an arbitrary reference circle, but a solid angle cannot be properly understood without reference to an arbitrary sphere. Light from a point source like a candle flame travels in the form of spherical wave fronts. These spheres have increasing radii at different distances from a source and form concentric spheres. Consider any sphere of a radius r at any instant. Consider a small area A on the surface of the sphere. If we draw a number of lines from the source S such that all of them touch the boundary of the region normally, these lines form a cone. The angle at the point S enclosed by the conical surface is called a solid angle. Solid angle is defined as the ratio of the area of the surface of the portion of the sphere enclosed by the conical surface, forming the angle to the square of the radius of the sphere. Mathematically, we can write solid angle as solid angle omega is equal to the surface area upon square of distance. That is, solid angle omega is equal to a by r square. The solid angle is the measure in steradians, that is SR. If A is 1 unit and R is 1 unit, then omega is equal to 1 steradian. As we know that area of sphere is 4 pi r square and radius of the sphere is r, then omega or solid angle equals to 4 pi r square upon r square, which is equal to 4 pi steradian. Thus, we can say that total solid angle for the sphere as a whole is given as 4 pi steradian. Here, look at the street light forming a solid angle. Now, let us understand what luminous intensity or illuminating power is. We can define luminous intensity as the luminous flux incident on a small surface which lies in a specified direction from a light source and is normal to this direction. It is divided by the solid angle which the surface subtends at the source of light. Luminous intensity is measured in candela. Mathematically, luminous intensity is written as luminous flux upon solid angle, that is pi by omega. Here L is equal to luminous intensity, phi is luminous flux, omega is the solid angle. If d phi is an amount of the luminous flux of a point source of light for a small solid angle d omega, the luminous intensity is given by d phi by d omega. Now, let's have a look on candela. A standard candle was used earlier to define the luminous intensity of a light source. But latest fundamental SI unit of luminous intensity is called candela, denoted by the symbol CD. Let us first replace the candle with the black body radiator. The black body radiator is nothing but solidifying platinum kept at 2046 Kelvin temperature. Let A be 1 square centimeter area. Let d omega be 1 steradian. Now, treat the entire sphere of radius r as a black body. Then, the light flux emitted from 1 by 60 portion of A gives the candela CD. We can define candela as luminous flux emitted per unit solid angle normal to the surface by 1/60th square centimeter area of black body radiator kept at a temperature 2046 Kelvin of solidifying platinum. A common candle emits light with a luminous intensity of roughly 1 candela. Now, let's have a look on lumen. The luminous flux of light source is measured in units of lumen. A lumen is a unit of luminous flux equal to the amount of light given out through a solid angle of 1 steradian by a point source of 1 candela intensity radiating uniformly in all directions. The symbol of lumen is Lm. Let me tell you what candle power is. Candle power, which is abbreviated as Cp, is now obsolete unit which was used to express levels of light intensity in terms of the light emitted by a candle of a specific size and constituent. In modern usage, candle power equates directly to the unit known as the candela. Thus, a candle power can be defined as a light source in a given direction is the luminous intensity of the source in that direction. It is expressed in candela. A source having an illuminating power of 1 candela in a given direction is said to be 1 candle power. The sunlight has its maximum radiant energy, that is 5550 angstrom. The typical luminosity value of some common light sources are: incandescent lamp 14 lumen per watt, fluorescent lamp 43 lumen per watt, halogen lamp 58 lumen per watt. The values mean that a 100 watt incandescent bulb would emit approximately a flux of 1400 luminous. This also means that the luminous intensity of illuminating power of a 100 watt bulb is about 118 candles. Luminous flux. Luminous flux can be defined as the light energy flowing from the source per unit time as perceived by a human eye. The units are lumen, that is Lm, solid angle omega, that is the ratio of the area of the conical surface to the square of the radius of the sphere. The units are steradians, SR. Luminous intensity I can be defined as the luminous flux emitted by the source per unit solid angle. The units are candela CD or lumen by steradians. Candela CD can be defined as the luminous intensity in the 1/60th of a square centimeter area. The units are candela CD. Lumen Lm is the luminous flux per unit solid angle per unit second. The units are lumen Lm. Candle power can be defined as the luminous intensity of a source in a given direction expressed in candela. The unit is CD, candela.